Something impossible just happened. It breaks everything we thought we knew about the universe. Do not look away. Not a scheduled briefing, not a press release, a silence, the kind that follows data nobody knows how to explain yet. Webb's latest transmissions contained readings that disappeared from public databases before most researchers could download them. What leaked before that happened is what you are about to hear: 100 galaxies, fully formed, massive, ancient, sitting in a period of cosmic history where, according to every equation ever written, every simulation ever run, they should not exist. Not surprising, not unexpected, impossible. To understand why that word is the correct one, you need to understand what the universe was supposed to look like at that age. The Big Bang happened 13.8 billion years ago, and in the first moments, matter itself could not hold together. Plasma so violently hot that a single hydrogen atom forming was immediately torn apart. The universe had to cool for hundreds of thousands of years before the simplest element could survive. From that hydrogen, gravity began its work. Slow, patient, relentless. Gas clouds collapsed, the first stars ignited, clusters merged, and across billions of years, galaxies slowly assembled themselves into the massive structures we observe today. Every simulation agreed. Small comes first. Large comes later. The early universe was supposed to look like a construction site. Scattered debris, raw material, dim, chaotic, primitive. Webb was sent to photograph that debris. Instead, it found the finished buildings already standing. These galaxies weren't slightly larger than expected, and some contained hundreds of billions of stars in a universe under 700 million years old. Our Milky Way, a galaxy that required 10 billion years to reach its current size, was apparently matched, exceeded, by structures that had almost no time to exist. Imagine you arrive at the construction site 3 weeks after ground was broken, and the skyscraper is complete. Same materials, same structure, just compressed into a time frame that makes the process physically impossible. Scientists did what scientists always do first. They looked for the simpler explanation: measurement error. Perhaps the distance calculations were simply wrong. That explanation held for 6 months. Then the spectroscopic confirmations arrived. The distances were real. The ages were real. The masses were real. The calibration argument died quietly. But there's a problem, a terrifying one. The next attempt was star formation efficiency. Maybe early galaxies were simply better at building stars, faster, more completely. The math demanded efficiency exceeding 100%. You cannot convert more gas into stars than you actually have. Reality did not contain enough substance to make it work. And then, the black holes. Galaxies and their central black holes grow together. They co-evolve. They are linked. Webb began detecting the luminous cores of actively feeding supermassive black holes at the same extreme distances as the anomalous galaxies. These black holes were not small. Several carried masses of over 1 billion times the mass of our Sun, in a universe under 1 billion years old. Standard theory says black holes grow slowly, constrained by the Eddington limit, a hard physical boundary. To grow this large, this fast, they would have to feed 8 or above that limit, continuously, from the very first moment stars existed. That is not how black holes behave. That is not how they have ever been observed to behave. But there's a problem, a terrifying one. Some researchers realized maybe black holes in the early universe did not grow to those sizes. Maybe they were born that way. This is where the theory gets genuinely unsettling. Standard models assume black holes begin as dying stars of 20 to 100 solar masses. But a new hypothesis proposes that in the early universe, massive gas clouds collapsed directly into black holes, without ever forming stars first. No stellar birth, no nuclear fusion, no supernova, just a gas cloud, collapsing, and becoming a black hole of 10,000 to 100,000 solar masses in a single catastrophic event. A seed the size of a small galaxy. If these monsters existed, the timeline problem vanishes. But proposing an entire class of cosmic object that formed and vanished just to save a broken model is the ultimate scientific desperation. But there's a problem, a terrifying one, because even if we explain the black holes, we cannot explain the dark matter. Dark matter makes up 27% of the universe. We have never seen it. We only know it exists because of the gravitational scaffolding it provides. Standard models assume dark matter is cold. It clusters gradually, building the skeleton for galaxies slowly. But Webb's galaxies suggest the skeleton was already finished, far earlier than the laws of physics allow. Some have proposed fuzzy dark matter, a quantum model where dark matter behaves like a wave rather than a particle. This could accelerate formation, but it has never been confirmed. We are stacking unknowns upon unknowns, dark matter of unknown type, behaving in unconfirmed ways to explain galaxies that shouldn't be there. But there's a problem, a terrifying one, because some researchers are no longer asking if the model is wrong. They are asking if the age of the universe itself is wrong. 13.8 billion years. We were told this number was settled, but new analysis suggests that if we revise our assumptions about physical constants, the actual age of the universe may be closer to 26.7 billion years, nearly double. If the universe is twice as old, the impossible becomes merely early. There was more time for gas to collapse, more time for stars to die. But the cost is the total destruction of everything we thought we knew about the Big Bang. It requires questioning the speed of light, the gravitational constant, the numbers that underpin every equation in physics. If the foundation is shifting, then every measurement we have ever made is a lie. What is accumulating is a convergence. Galaxies too massive, black holes too large, chemistry too enriched, expansion too fast. A universe that may be twice as old as we were taught. The models were not off by a small margin. They were off by a factor of hundreds. The lambda cold dark matter framework is the operating system of modern cosmology. Everything is connected. A failure in one section propagates through the entire system. Pull one thread, and the entire fabric moves. The honest answer? Webb has not broken physics. Not yet. What it has done is expose a gap between what we predicted and what the universe contains. That gap is measured. It is documented. And it is growing with every new transmission. Whatever happened in those first few 100 million years? It was not following our script. We were certain of our beginning. Now, we are certain of nothing. We are not saying the universe is broken. We are saying the map is broken. And somewhere in that gap, an answer is waiting. One that will either save our science or replace it entirely. So here is what we want to know. If the universe is twice as old, if dark matter isn't what we thought, what do you think this could be? Drop your theory below.